Welcome to Homework Lib.
Because this logarithm is not too sharp, let's explore um, log base 2 of x, log as the parent function. So log base 2 of 1 is 0, log base 2 of 2 is 1, log base 2 of 4 is 2 because 2 squared is 4. And so the logarithmic function, which I'm doing in black, would be the parent function log base 2 of x. Now, some things that immediately draw attention here is that we could reflect this over the y-axis to match it. Now, what is that going to look like? That would become, and I'll do this one in blue, log base 2 of negative x. That would flip it over horizontally. And that's what we'd have. It looks like it doesn't match it quite exactly yet. At this point, I would move it now 4 to the right. And 4 to the right would be now normally it would be opposite because the negative I'd actually do plus 4 here. And that is because this is equivalent to gets tricky. Here's why, because it would be the negative of x minus 4. And we can write it like this. That I think might make more sense to you if you're studying transformations. This I will do in green, and if we just shifted this thing over 4, I like it because it really has the same shape, and it goes through the same 0 at 3. So it's going through 3, 0 right now. It's just that at -2, it's going through it's not quite going through where we need it to go to, like the y-intercept, for instance, is 2 instead of 1.5, but that can help us with a vertical stretch. And so if we do a vertical shrink in this case, if we want it to go to 3/4, we want it to go to 1.5, and it's at 2, then we can think about what that scale factor should be equal to for that vertical stretch. And this would be equal to 3/4. So if we put a 3/4 vertical shrink out front, then I believe that will match up perfectly here. And so our function should be 3/4 log base 2 of negative of x minus 4, or negative x plus 4 if you'd rather.